Hello everyone, welcome to my channel Coding Together. My name is Vikas Oja. Today we will see another Leetcode problem, that is n queens. So let's read the problem statement. The n queens puzzle is the problem of placing n queens on an n into n chessboard such that no two queens attack each other. Given an integer n, return all distinct solutions to the n queens puzzle. You may return the answer in any order. Let's talk about the constraints as stated in the question. So suppose if I place the queen at this cell, so I cannot place the second queen in this cell or this cell or this cell or all the cells highlighted by cross, because we cannot place two queens in the same column or in the same row or in the same diagonals, because queen can attack vertically, horizontally and diagonally. So I can place the next queen in these locations, right? So we'll use backtracking to solve this question, because we have to try all the possible solutions, right? And we have to backtrack as soon as we see that the possible candidate of the solution is not going to lead to a valid solution. So we'll place the first queen at this cell, because at the start all the cells are empty, right? And there is no queen. So first we'll place this queen in the first cell of the first column. We'll go column by column, right? If we have placed a queen in the first column, then the second queen we will place in the second column, third queen in the third column, and fourth queen in the fourth column. So I have placed the first queen in the first cell of the first column, right? Now for the second column, the second queen for the second column, I cannot place the queen at this cell, right? Because they would be in the same row. I cannot place the queen in this cell because they will be diagonal. I can place the queen in this cell, so I'll place the queen in this cell. Now for the third column, for the third column, I cannot place the queen in this location, right? Because it will be in the same row as one of the queen, right? So this queen can attack this queen if I place this. Now I cannot place the queen in this cell because it will be attacked by this queen. I cannot place the queen at this location, right? Because it will be attacked by this queen. And I cannot place the queen at this in this cell because it will be attacked by this queen. So for this column there is no place for any queen, so we have to backtrack. Because this will not lead to a feasible solution, right? Because we have not placed any queen for the third column, and as we know, we have to place at least 4 queens for a 4x4 board. So means we'll backtrack. So when we backtrack, we have to remove this queen, right? We have to remove this queen, because if we place queen at this in this cell, we are not going to have any solution. So if we backtrack, we have the queen here and we will not place the queen here. So as we know, we cannot. So we have tried these 3 options, right? These 3 positions. So I'll place the queen at this location, because this will not be attacked by the first queen, right? Now for the third column and the third queen, I cannot place the queen in this location, but I can place the queen in this location, right? Because this will not be attacked by this queen and this queen will not be attacked by this queen. So none of the 3 will attack each other. Now for the fourth column, I cannot place the queen at this location. I cannot place the queen at this location. I cannot place the queen at this location. I cannot place the queen at this location, right? So because I cannot place the queen for the last column, I have to backtrack. So I have to backtrack, right? So this position of the queen for the third column is not correct, right? So I have to try another position. So if I remove this position of the queen, can I try this position, the next position? No, because this will be attacked by the queen, this queen, and I cannot place at this position and at this position. So I have to backtrack again, right? I have to remove this position as well. So as this is the last position, right? As this is the last position, we have to backtrack again, right? We'll backtrack again, right? We'll backtrack again and we'll change, undo the last position. So we have to mark this as cross, right? So this is also marked coin, and this is the last cell of this column, so we have to backtrack. And so this means if I place queen here in the first cell, it will not lead to a possible solution, so we have to remove this cell as well. So now we have to place the queen in the, we have to try placing the queen in the second cell. So we started with the first cell of the first column. Now we'll start with the second cell of the first column, right? So if I place the queen in the second cell of the first column, can I place for the second column, right? I cannot place the queen at this location. I cannot place the queen at this location, but I can place the queen at this location, right? If I place the queen at this location, now for the third column, I can place the queen at this location, right? Because it will not be attacked by this queen and it will not be attacked by this queen. Now for the fourth column, I cannot place the queen at this location. I cannot place the queen at this location, but I can place the queen at this location, right? It will not be attacked by this queen, and this queen. So this is our valid solution. So this is our possible solution. Now we have find our feasible solution, so we'll backtrack. So when we backtrack from this column to this column, now I have to try from, apart from this cell, the other three cells that we have not chosen. So can we put, so if I started from this, now I had for this the queen placed at this cell, we had a possible feasible solution. Now we have to try with this cell. Can we place the queen here? No, because it will be attacked by this queen. Can we place the queen at this location? No, because it will be attacked by this position, and we cannot place the queen at this cell. So these other three cells are not possible, right? So the only solution was this one first. Now we'll backtrack again. So we backtrack from this column to this column. Now we'll backtrack. Now as the queen is already placed at the last cell, so there is no possible solution, so we'll backtrack, right? We'll backtrack. Now the solution that we have to try is placing the queen in the next cell of the first column. So we'll place the queen here in the next cell, right? And we'll start placing the queens in the next columns, in the subsequent columns. So for the second column, I can place the queen at this position. For the third column, I cannot place the queen here, right? I cannot place the queen here, I cannot place the queen here, but I can place the queen at this location. For the fourth column, I cannot place the queen here, right? I can place the queen here, right? Because it will not be attacked by this queen, nor it will not be attacked by this queen, and it will not be attacked by this queen. So this is the other feasible solution, right? So we'll backtrack to to this column. So as the queen is already in the last cell of the third column, so we'll backtrack again. So we'll see whether now here the queen is placed in the first cell, so we have to try with the other three cells, right? So if the queen is, so we backtrack from here to here, right? Now we will see whether we can place the queen at this cell. No, because it will be attacked by this queen. Can we place the queen here? No, it will be attacked by this queen. Can we place the queen here? No, because it will be attacked by this queen. So we have to backtrack again, right? So when we have to backtrack, now the only chance is to place the queen to here, to move the queen from third cell of the first column to the fourth cell here. So we'll place the queen in the last cell of the first column. So can we place the queen in the first, for the second column we can place the queen here? Yes. For the third column we cannot place the queen here, we cannot place the queen here, but we can place the queen in this location, right? For the fourth column, can we place the queen in this cell? No. In this cell? No. In this cell? No. No, we cannot place in any of the four cells of the fourth column, so we'll backtrack. Now the queen is already placed in this cell, so we have to place the queen in the last cell. So can we place the queen in the last cell? No, right? So we cannot place the queen in the last cell, right? So we have to backtrack again. So the queen was in the first cell of the second column, right? So we have to see the next cell, right? So for the next cell, can we put the queen? Yes. So suppose we place the queen here and we place the queen here. For the third column, can we place the queen here? No. 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 So for the third column we cannot place the queen in any place, so we'll backtrack. So we'll move the queen from here to, we'll undo the queen, we'll undo the changes, we'll move the queen to the, we'll see the other possible solution. So can we place the queen here? No. Can we place the queen here? No. So there is no choice, so there is no possible solutions, so we will backtrack. So for, as the queen is already placed in the last cell of the first column, so there is no choices left, so we'll return. So we'll return, there is no other choices, we have exhausted all the solutions. So what are the two possible solutions? This and this. So let's see the code part for it. This is the Java implementation of the nQueen problem that we discussed. I have created a 2D board of character type with the rows and columns both as n, and we have I've initialized all the cells with a character dot. Now we are calling the DFS, depth first search. So we are starting our DFS method. So we are passing the board that we created, the column. So column is the 0th column, that is the first column. We'll start with the first column, and the result, that is a list of list. So if column is equal to board.length, that means we have placed all the queens in each of the column, meeting our constraint, like the no two queens attack each other. Then we will construct the board and we'll add into the result. So what do we do in the construct of the board? First we convert each row of the board, and convert each row of the board into a string, right? So we take each character of the cell, convert it into a string, and add that string into the list. So the complete solution is a list of string, and we add that list of string into the resultant list of list. Now we will start the for loop from I equal to 0 and I less than board.length. So it means we are starting for each row, right? We are going column wise, but we are placing the queen at each cell row wise for each column. So for the first column, we have started with the placing the queen in the first cell. For the second column, we check whether we can place the queen in the first cell, second cell, third cell, right? That is what we are doing in this with this for loop. And we are calling the validate method with the board that we created. I represents the row and the column. So what do we do in the validate? In the validate, we check that if we place queen in a particular cell, right? If we place the queen in a particular cell, is there any queen in the same row or in the same diagonal, right? In the same diagonal up or in the same diagonal down, right? So this first loop is for the row, second loop is for the diagonal up, and third loop is for the diagonal down, right? So if you see, we are doing I is equal to 0 and I less than column. So right, if we are working on a particular column, right, suppose the third column, so we'll check for the first column and the second column whether in the same row, for the same row, there is a queen present or not. Similarly, we'll do row -1. We'll start with row -1 and column -1. So when we do row -1 and column -1, it means that the diagonal up cell, right, diagonally up cells will move, and will keep on moving until the I is greater than equal to 0 and j is greater than 0. And if the board ij becomes equal to q, then we return false, means there is already a queen present there. Similarly, we'll do for the diagonal down. So if the validate is true at the location I comma column, then we'll place the queen at in that cell for that column, and we'll do the DFS again over the board and the next column, that is col +1, right? We'll again check whether we can place in the next column. And once we are over with the either the feasible or non-feasible solutions, we'll backtrack by reverting the position of the queen at I comma call. So at I comma call, we place the queen. So once it leads to the feasible or non-feasible solution, we'll backtrack by replacing the queen with the dot. So once this DFS is over, we'll return the result. So yes, test cases are accepted. So means this solution is working fine. So I hope you like this video, and if you enjoyed this video, please share and subscribe. Thanks for watching.